Hello everyone, this is me. In this section, we are going to go through the hands-on session for recurrent neural network. Same as before, on our course homepage, at the notebook section, there is a recurrent neural network notebook. Let's copy the address, copy the link address. After you copied the link address, let's go to the DataBrick Community Edition online user account. So same as before, let's click on Workspace. In this white space here, right-click, import URL, and paste the link we just copied. And then click import. The import basically is going to make the notebook using the link to be your own notebook in your own computation environment. We are going to attach the computing environment we created, and then click Run All right here. Because it's going to download the required library and run the recurrent neural network. It's going to take a little while, so let's just let it run, and I'm going to walk through the details of using Keras library for recurrent neural network. So in this particular notebook, there are a lot of useful materials that we adopted. Most of them actually in the Keras authors webpage, in RStudio's webpage here. A lot of useful information. Same as before, basically we have to install the package, the Keras package. It's going to take a little while because it has to download a lot of needed libraries. And then once the download has finished, then we're going to call the library Keras function and install _Keras, basically using different version of the TensorFlow. Because there are a lot of it's fast changing environment, because TensorFlow has been updated pretty quickly, so the scripts that it can run is basically for that particular version, and we need to make sure the TensorFlow equal nightly is included in this function. The dataset. So the dataset is the IMDb dataset, which include the response variable is going to be either a positive or negative sentiment. The input, the movie reviews at the IMDb website. So first is basically the data pre-processing stage. What we need to do is basically to tell the program what kind of setup we want for this particular natural language processing problem. The first parameter is actually what we define the size of the vocabulary, because people try to use all different kind of words in the movie review. So the unique number of words is huge, but to make the computation and the encoding a little bit easier, we're going to define the maximum number of unique words in the training data. So by frequency, ranked by frequency, the most frequent word is rank 1, etc., etc. We're going to go from the most frequent to the 2,500 in rank in this particular setup. Any of the words with frequency that the rank is lower will be replaced by a special number. And then they are going to be words will be replaced by their rank. So the second parameter is the length of the review, because the review can be as short as one word or as long as a few hundred, 3,000. Some people tend to write longer reviews, some tend to write shorter reviews. But in this particular example, we have to make sure the reviews, they're going to have the same length. So we set up the length to be 100 words. Any reviews that is more than 100 words, we're going to do the truncation. For any review that is less than 100 words, we are going to do the padding a special integer there. So once we define those two parameters, we can just simply call the dataset underscore IMDb function to return the training data as well as the testing data that we want. So if we look at the basically the X, we can see those are the word we see here. There by the numbers, it's the rank for the word by frequency. One is a special character, which means the beginning of the review. There are a few other special meanings, like padding 0, I think, and as well as a special word integer 2, which is representing any of the words they are actually has lower frequency, not within the 2,500 words chosen. So we can get the training data, testing data, X and Y from the function to load the data. So we're going to pad the frequency, we're going to pad the X variables or truncate based on the max length, the maximum number of words in each review. So after that, we're going to have our review training data as well as the features and response. Response is going to be either 1 or 0. The input data, we're going to have 100 features for each row. So that's basically the initial data pre-processing. Once that is done, we can actually feed a simple recurrent neural network. By first, we create a placeholder by calling carries underscore model underscore sequential function, and then for RNN, we have to actually either using a particular embedding or train the embedding on the fly. So in this particular example, we actually have the embedding layer. We have the input dimension, which is basically the maximum unique word to 2,500, and output dimension is 128. So we can either do a one-hot encoding, which is not efficient at all for this RNN, or we can do encoding. Encoding is going to be instead of each word, we use 2,500 columns of 1 or 0 to represent. We are actually reduce them to 128 columns, and the input is real numbers. So that's the embedding. Layer underscore simple underscore RNN is a simple RNN neural network. We define a few parameters here, and then at the end we are going to add a dense layer, same as before, because we have to connect the result to the final outcome. In this case, a binary classification problem. Once we define the model, we're going to define what's the loss function, what's the optimizer, and what kind of metrics to follow, same as before. And then we are going to feed the model by define what is the training data, X, Y, the batch size, how many epochs to run, etc. Then actually the model is up and running. For this particular case, after the number of epochs we defined, we see the accuracy here. So for this one, it's run for less than a minute. So you can see still the accuracy is still increase, but it's kind of like we're going to see some overfitting maybe after the number of 5 epochs. So this is a very simple RNN model. We evaluate, we look at the performance. So the overall performance accuracy is 66%. I think it's okay. It's a good starting point. But we all know our simple RNN is not exactly the best method to use. Let's use the LSTM RNN model. To define a LSTM RNN model is straightforward. The only difference is this layer here. We're going to replace the layer simple RNN by layer underscore LSTM, and then everything else are the same. So we run this particular model because the LSTM is going to use more computation. So for this one, it is around 3 minutes to finish. But the accuracy is much higher. It's already at 87, 86, 87 range. So much better than the simple RNN model. So we apply the model to our testing data, and the overall performance is around 84%. So yeah, that's all for the RNN model. So we only touch the very surface of the RNN model of basically how we can leverage carries to very easily create a NLP model.